let's talk about electric field. So we can say that electrical field is a concept. Okay. When we say two charged body, one is considered to be a source charge according to which we are going to calculate, and we consider another test charge, that is Q naught. Some force is acting between these two. Okay, so the electric force acts between the two charges bodies even without any direct contact between them, means they are going to attract or repel. If we consider this as also a positive body, they will going to repel and the force will going to act in this direction. Okay, so it is assumed that the charge q that we are taking produce an electrical environment in this surrounding. Okay, वो सब जगह पे produce कर रहा है in that surrounding, and that is called as electric field. And if we talk about that electric field, we can also define that electrical field at a point. We can say that the electrostatic force per unit test charge acting on vanishingly small positive test charge that placed at that point, that is known as electric field. And electrical field we can write over here, that is E equals to F by test charge. Sometime it is written over here limit. Limit means it is a point charge or vanishingly small charge. That's why we are writing here is Q naught. Okay. Now, if we talk about its units and dimensional, what will be the unit? We can say force is Newton, charge is in Coulomb. So the SI unit is Newton Coulomb. And equivalent can also be written in another terms, that is in voltage. If we are talking about a potential difference, we know potential difference, that is V equals to work done in a unit positive charge. Okay, and work done we know that is force into displacement upon test charge. And force, from the above formula we can say that force can also be written as QE. Okay, F is subject, then F equals to QE and D upon, if we are talking about test charge, then it is test charge. We cancel it out, then we can say E into D. Okay, then voltage can also be termed as E dot D. And in terms, now we need to find electrical field. So electrical field का new formula what we will get here, E equals to V by D, that is volt per meter. Okay, that's V is volt potential difference that measured in meter. So and distance is in meter. The unit is volt per meter, or we can say right here volt meter inverse. These are the SI units. If we talk about the dimensional formula we can calculate it in terms of, that is E equals to force by charge. Okay, Q, force is M L T minus 2 upon Coulomb. By placing it Coulomb, that is ampere ampere time, that is Q equals to IT. In terms of that we can take it. So we will get here, if we replace this MLT minus 2 upon AT, ampere in time, we will get MLT minus 3. Okay, and ampere minus 1, dimensional formula. So from the above we can also see that if we are make an imaginary things, that force equals to charge into electrical field, we can say that wherever the force is acting, there is two things need to be present, that is charge and electrical field. If we place these two charges, so we can say here is a charge, here is also a charge, and in between them, to interact in between them, we can say there is electrical field should be present. Electric field. Okay, then they will attract or repel which one ever they want to be. So this is a simple understanding. That is, to apply a force we need a field if the charges are present there. Now if someone asks you, okay, what they ask in terms of find electrical field due to a point charge. Okay, how can we define that? We can imagine a test charge as we seen above, and we place it. So here it is a source charge, that is Q, and we place a test charge Q naught. In between, अगर हम इसको connect करते हैं, if we connect this, then we can say it is providing the position at what distance it will be. Okay, and the force is in same direction, that position from the source charge. Okay, it is source. Now if it is applying in this direction, what will be the force over here? That is applying according to the formula that we know, K Q naught upon R square, and it is pointing in this direction. This is our unit vector. If we are talking about this direction is in the direction of this vector, so that is showing me a unit vector over here. So now we need to find the electrical field. Electrical field is nothing, that is E equals to F by Q naught. If we talk about this, then we have the value of K Q naught upon R square, unit vector, and in terms of Q we will place here over here Q naught. It will strike out, and again electrical field will be K Q by R square and unit vector. That is our electric field. So as we proved above, that is electrical field is KQ by R square. We can also get this formula from this. So don't get confused if someone asks you a point charge, it will be the remain same. And this electrical field also can be said as, it is also following the inverse square law, that is 1 upon R square is inversely proportional to this R square. Okay, so please do take care of this. And we can also say that if we place a charge, test charge, or no, sorry, we place a source charge, okay, then it points an spherical surface drawn around this source charge with a magnitude of E and same, and it does not depend on the direction. Why it does not depend? Because if I draw here a point, then it is electrical field in this direction. If I draw a point here, then it is going in this direction. So all over the charge in the surrounding, the electrical field is going to distribute. So we can draw this in all the direction. Okay, that's it. Okay, thank you.